Hello. Hi everyone. What's up? Good morning to everyone, whoever is here. Let me quickly see if everything is good. Looks good. Thank you so much, Shiv, Gikari, Frog, Fennect, and Satok for following over the last 15 days. That is great. So it's good to know that people are, getting to know about it either by either through me or through somewhere else. So that is good. Today's morning we are going to continue learning Rust. Sorry, there's an alarm. I need to put my phone on silent. So the time is 6:30 a.m. in the morning in India. So that is great that we have made some progress. Today what we are going to learn about is basically continue learning Rust, right? So earlier we had done the starting 5 chapters where we talked about vectors, strings, slices, all of those things, right? Just the basic stuff. Now today what we're going to do is we're going to continue working on struct, probably traits as well, types, what kind of types are there. So we have a lot to learn today, so that is great. Okay. And then I have set up my new Vim, so I'm just excited to use it now, just for my own purpose. All right, so I think we can start. I just want to quickly update on Discord that hey, we are live, so I can do that now. Stream notifications at here. Oops, I think I hit the enter first. Live now. Join me on Twitch. And I can share the link. Today's menu will be Rust plus my new Vim setup. Cool. All right, so there you go. It is done and we are good to go. All right, so let's start, right? Where do we start? So probably the best place to start with would be check if my voice is okay. Yeah, I think I'm all good. Let me quickly check again. Wait, what happened? Yeah, looks good to me. Awesome. All right. So let's go to CD documents project KR Shimali open source. Was it open source? Was it something at streams? Yeah. Rust and day one. So in day one, we just went through some of the stuff that we were trying to understand, which is good. So I don't think we need that anymore. So we'll go to day two. Right, so that is it. That is the initialization of what we want to do today. So let's go to Rust Lang book. Read the book. Yeah, that is good. Read the book. Yeah. All right. Where's the dark theme? Where's the dark theme? There you go. Got it. So that is surprising. We didn't do. We only could do the starting 4 chapters. Today we have to do the 5th chapter. Let's target 6th chapter. Managing growing projects with packages, crates, and modules. Maybe 7th as well. I don't know why these build systems are important, but they are boring for me. Common collections, error handling, generic types, writing automated tests. That would be great to learn. All right, so today we are going to check about defining and instantiating structs. All right, let me drink my tea before it gets cold. The Indian tea. So structs are similar to tuples discussed in the tuple type section in that both hold multiple related values. So in the way that the type of values they can hold, structs are similar to tuples because they can hold multiple related values. Maybe I can take some notes. Structs chapter 5 can take multiple related values. Why have they used multiple related values? Is there any reason for that? So like tuples, the pieces of a struct can be different types. Yeah, unlike with tuples, in a struct you will name each piece of data, so it's clear what the values mean. All right, so that makes sense. So I've just pasted it here. I will do set wrap so that it's good. Adding these names means the structs are more flexible than tuples. You don't have to rely on the order of the data to specify for the access the values of an instance. Yes, so you don't have to worry about the order since you've entered the names, right? So that makes sense. So define a struct. We enter the keyword struct in the name and name the entire struct. The struct's name should describe the significance of the pieces of data being grouped together. Then inside curly brackets, yeah, that is good. Like just awesome. Cool. So it's just like struct name, field name, and type, which is optional, right? And there you go. Right, so that looks good. To use a struct after we have defined it, we create an instance of that struct by specifying concrete values for each of the fields. We create an instance by stating the name of the struct and then add curly brackets containing key value pairs. Where the keys are the names of the fields and the values are the data we want to store in those fields. We don't have to specify the fields in the same order in which we declare them in the struct. In other words, yeah, that is good. So let user1 equal to user, and then you put a curly brace, you define all the field names and then you give them the values, right? Key value pair. And there you go. That is it. To get a specific value from a struct, we use dot notation. Yeah, that is good. Nothing so special so far. Okay. All right. So you can also assign it. So you can also change the value. So that is great. So it's not like these are mutable by default. Okay. So you can also, for mutable user instance. Yeah, that is true, right? User, there you go. Yeah. So you have to create the instance as a mutable object. Right, there you go. So this is how you'll do that. And if you want to access anything, you can do something like this. Right, something like this is good. Note that the entire instance must be mutable. Rust does not allow us to mark only certain values as mutable. As with any expression, we can construct a new instance of the struct as the last expression in the function body to implicitly return that new instance. So you cannot have email or username as immutable and then active and sign in count as mutable at the same point of time for a same instance, right? So either the instance will be mutable or it will not be mutable. It will not be mutable or it will be mutable. That is it. So here the listing shows how to use a build user function for that. If you're given an email and username, and you can pass in the defaults. It makes sense to name the function parameters with the same name as the struct fields, but having to repeat the email and username field names and variables is a bit tedious. If the struct had more fields, repeating each name would get more annoying. There is a convenient shorthand using the field init shorthand. Because the parameter names in the struct field names are exactly the same. In listing 5.4, we can use the field init shorthand syntax to rewrite build user so that it behaves exactly the same, but doesn't have the repetition of email and username. Okay. So that's what they mean, right? So, which is good. So probably what we can do is you can use build user, pass in the email and username, and just say that user, it returns a user instance, right? Which is a struct name. And here you can just pass email and username as it is. So you don't have to do something like, email, this email, comma, right? You don't have to do that. So, which is great, right? That helps. There you go. So you don't have to do that, and you can just pass email and username, which is good. But the order matters, right? What about that? So okay, it takes that as a name itself. Here we are creating a new instance of the user struct which has a field name email. We want to set the email field's value to the value in the email parameter of the build user function. Because the email field and the email parameter have the same name, we only need to write the email rather than email. What I'm curious about is, so let's actually create a cargo new sample here, and what I'm going to do is I'm going to go to sample src main.rs. So let's create a struct. Okay, I'm getting this bug recently on while using Rust Analyzer, so that's okay. What I want to check here is if I do struct sample, right? Let's say field 1, which is an I32, and field 2, which is U32. Okay, or maybe U size. Okay, and if I do sample, uh, and here you go. So my question is, if I do field 2, which is, let's say, 3, okay, and field 1 as it is, right? And if I do let field 1 equal to 10, so what will happen? Is there any error? Field is never used. Field 1. Okay. Okay. Field 2 is not used. That is crazy. Okay. Can I get rid of them? Unused variable sample dot. So let's just do println. How do you derive? Derive std fmt display. Just so let's just look at display. How can I derive it? Okay, so you need to impl it for the structure. All right. We'll do impl fmt display for sample, right? And here we can do use std fmt. So format, right? So we can now define it here. We can do println. We need to define the function fmt. Okay, I think we can do this. There you go. It results. Sorry. So what is it? Formatter. This trait requires format with this exact signature, right? Strictly the first element into the supplied output. So, okay. What we can do here is just follow the documentation. Write f. What is that? F, yeah. Okay. Formatter. And do this and do cell.0. And we can have we need to use double quotes. So is that it? That's all we want to do. Okay, I need to derive it as well. So the format is like this, square bracket derive, and then you do display. Is that how you do it? So how? So I don't need to do this, is it? And this should work. Okay, so you can probably make it better, that you can do oh, so there you go. Now it is solved. And if I do cargo build now, if I do cargo run, there you go, 10,3 is printed, right? So that works. So if you want to print the structure, you need to implement the display, and that's it. All right. Sounds good. And for generic types, you can use derive debug. Hmm. Right, right. Mostly people use for debug when they want the output to be, better. So if I would have done derive debug, and if I would have commented this out, hmm, sample does not implement. Yeah, in that case, we just did right. So, all right. So it makes sense to name the function. Yeah, using the field init shorthand, we have just like we can see that it also works. I was just curious, is it like you cannot pass a shorthand syntax after this field to 3 kind of thing, right? So that works. So no issues at all. So creating instances from other instances with struct update syntax, right? Okay, can I please get rid of it? This is much better. That is a whole innovation. So where was it? Yeah, it's often useful to create a new instance of a struct that includes most of the values from another instance but changes some. Okay, you can do this using struct update syntax. So like for example, we have sample here with field 2 as 3 and field 1 as 10. Can create another instance, is it, with some different values from this? So first we create this struct of user2 using struct update syntax. We just take user, email string from, and dot user1. So everything that comes from user1, where do we have user1? So where do we have user1? String from another @example.com. I don't know. Mm, in the given instance, the code also creates an instance in user2 that has different values for email, but has the same values for everything from user1. But bro, where is user1? That is a mistake, is it? Yeah, that looks like a mistake to me. I don't know. Creating a new user. Oh, sorry. From using one of the values from user one. Okay. So using user one dot active, user one dot username, user one dot sign in count. So that's like quite tiring. So you can just do email and provide a email, and then you can do user one. So that was a little confusing. Cool. The user one must come last to specify that any remaining field should get their values from the corresponding fields in user one. But we can choose to specify values for as many fields as we want in any order, regardless of the order of the fields in the struct definition. Note that the struct update syntax uses equal to like an assignment. This is because it moves the data just as we saw in this. In this example, we can no longer use user1 after creating user2 because the string in the username field of the user1 was moved into user2. If we had given user2 new string values for both email and username, and thus, okay. Okay, so the behavior in the copy stack only data copy would apply. So this is interesting. If we had given user2 new string values for both email and username, and thus only use the active and silent count values from user 1, then user 1 would still be valid after creating user 2. Okay, so it's like a copy syntax. So it doesn't do this move thing. So because they implement the copy trait. So Rust also supports the support structs that look similar to tuples called tuple structs. Tuple structs have the added meaning the struct name provider but don't have names associated with the fields. Rather, they just have the types of the fields. Tuple structs are useful when you want to give the whole tuple a name and make the tuple a different type from other tuples, and then naming each field as in regular struct would be verbose or redundant. Let black equal to color and point that way. To define a tuple struct, start with the struct keyword and the struct name followed by the types in a tuple. For example, here we define use two tuple structs, name, color, and point. Note that the black and origin values are different types because they are instances of different tuple structs. Each struct you define is its own type, even though the fields within struct have the same types. For example, a function that takes a parameter of type color cannot take a pointer. A point is an argument, even though both types are made up of three I32 values. Otherwise, tuple struct instances behave like tuples. You can destructure them into their individual places. You can use a dot followed by whatever. Unit-like structs without any fields. So you can always define structs that don't have any fields. These are called unit-like structs because they behave similarly to just an empty parenthesis. The unit type that we mentioned, tuple type section. Unit-like structs can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. Declaring instancing in a struct named always equal. Let subject equal to always equal. So you don't have any data to store in the type itself, right? But you need to implement a trait on some type. Okay. To define always equal, we use struct keyword, the name we want, then a semicolon. No need for curly brackets or parenthesis. Then we can get instance of always equal in subject variable and similar way using the name we define without any curly brackets for parenthesis. Imagine that later we'll implement the behavior for this type such that every instance of always equal is always equal to every instance of any other type. For us to have a known result for testing purposes, we would not need any data to implement the behavior. You will see in chapter 10 how to define traits in In the user struct definition listing 5.1, we use the own string type rather than the string slice type. This is a deliberate choice because we want each instance of the struct to own all of its data and for that data to be valid for as long as the entire struct is valid. It's also possible for structs to store references to data owned by something else, but to do so requires the use of lifetimes, a Rust feature that we'll discuss in chapter 10. Lifetime ensures that the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in a struct without specifying lifetimes like the following. This won't work. So you're doing email someone in the example. So there you go. You're doing string slice type and that will not work. Expected named lifetime parameter. Missing lifetime specify here. There you go. You need to do this. In chapter 10, we'll discuss how to fix these errors. So you can store references in structs, but for now we'll fix errors like these using own types like string instead of references like ampersand star. So an example program using structs. Okay. This is good. Refactoring with tuples. Okay. Mm. Hmm. Guys, I hope there's no noise from the background. Let me quickly check. Where's my OBS? Oh god, am I even streaming? Sir, where are you? There you go. Okay. So I needed to reduce the voice. I hope it is still okay. Let me check. So yeah, in the future, let me know if this level is not good. So I need to come closer to the mic now and be more loud. I hope it doesn't get worse. So right, adding useful functionality with derived traits. It would be useful to be able to print an instance of rectangle. Okay. Yeah, right. There's some echo, right? All right. So it would be useful to be able to print an instance of rectangle while we are debugging our program and see the values of all the fields. So this tries using the println macro and it will probably not work. Yeah, so you need to implement it. The println macro can do many kinds of formatting and by default the curly brackets tell println to use formatting known as display output intended for direct and user consumption. The primitive types we have seen so far implement display by default because there is only one way you'd want to show one or any other primitive type to a user. But with structs, the way println works is different, right? So we need to look at that. Um, right. So how do you do that? Do you want to print the curly brackets? Should all the fields be shown? Yeah, right. So if we continue reading the rest, we'll find this helpful note. The strut format display is not, is it format, right? It's not implemented for rectangle. In format strings, you may be able to use question mark or this for pretty print instead. Let's try it. The println macro will now look like println rectn is rect1 is, and there you go. You put the question mark. Putting the specifier colon question mark inside the curly brackets tells println we want to use an output format called debug. The debug trait enables us to print our struct in a way that it is useful for developers so we can see its values while we are debugging our code. Compile the code with this change that we see, we still get an error. Drat. How do you pronounce it? Is it drat? Shit. It's like shit. Alright, sorry. So, but again, the compiler gives us a helpful note that the trait debug is not yet implemented. So you need to do hash square brackets derive open parenthesis debug to rectangle or mutually impel debug for rectangle. Let's just include functionality to print out debug information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute just before the struct definition, right? And that is it. Now, when we run the program, we won't get any errors. We'll see the following output. We'll get the rect1 is rectangle, and you'll get this nice. It's not the prettiest output, but it shows the values of all the fields for this instance, which will definitely help during debugging. When we have larger structs, it's useful to have output that's a bit easier to read. In those cases, we can use colon hashtag question mark instead of colon question mark in the println string. In this example, using this will kind of make it pretty print. Another way to print out a value using the debug format is also to use dbg exclamation macro, which takes the ownership of an expression, prints the file and line number of where that debug macro call occurs in your code along the resulting value of that expression and returns ownership of that value. Calling the debug macro prints to the standard error console stream stderr as opposed to println, which points to stdout. We'll talk more about these streams in chapter 12, but that is important, right? So if I would have done dbg and if I would have done sample, right, and if I borrow of what does it say? Okay, I think so. Borrow of moved value, sample value borrowed here often, here after move. Okay, so you're not allowed to do that because. So I think what I can probably do is this cargo build, cargo run. So that works. So what I can do is I can also do this, and I can and. Hmm. Unused import. Field is never read. Field 2, that is okay. Sample has a derived impl for trait, but this is intentionally ignored. Why? Why, sir? During. Why do you not show me the whole? I don't know what's the error. Invalid provider doc list, so we'll have to fix that. Okay, remind me about it. It should be doc fix, I guess. We'll see. Anyways, for now, I'm gonna do cargo run. It's gonna automatically build it for me. It says field is never used. Field 2, that is okay. Sample has a derived impl for the trait debug, but this is intentionally ignored during that code analysis. Okay, this warning originates in the derive macro debug in nightly base run with. Okay, so there you go, you get it much better, right? Src main.rs line number 22 sample equal to this, and that's it, right? So it takes the ownership. Press the file line number of where that debug macro calls. Okay, that is good. Calling the debug macro prints to the standard error console. Okay, here's an example where we're interested in the value that gets assigned to the width field as well as the value of the whole struct in rect1. Right, there you go. dbg. Oh, wait, what? We can put dbg around debug around the expression 30 into scale, and because debug returns ownership of that expression's value, the width field will get the same value as if we didn't have the debug call there. We don't want debug to take ownership of rect1, so we use a reference to rect1 in the next call. Interesting stuff, my friend. I see what is happening. Okay, so this returns the ownership, so width will still get 30 into scale. I see, that is very interesting, right? So I can do dbg and I can do 100 into 100, right? And if I do cargo run, it will still work. And there you go, it says src main.rs 100 into 100. That is outstanding, right? So you can just do that and it will work. Say, let's say you don't, let's say in scale is 0.5, 0.05, okay, and you do scale, right? And if I do tf cargo run, yeah, I should fail. Ah, my bad. Sorry. It's F64. Yeah, nice. So an implementation for integer to float. That is good. So I was just, I think we read about it, right? With Python, the types are automatically changed to something which is more suitable, but here it is not the case. So what I can do is probably do, I can do as I32. I don't need this, right? If this works, I'm gonna give you guys a party. Yeah, I mean, not now, but yeah, that is great. Hey, why did you? That is funny, right? I said 100 into scale is, so it printed that for me. Come on, don't do that. 30 into scale equal to 60. Oh, sorry. Okay. See, it printed the value for me. It didn't print the scale. Of course, that is true. So it doesn't do that, right? So it said 100 into scale as I30 equal to 0. So the value is 0, the output is 0, but will not replace scale for you, which is good. We don't want that, right? We want to see what's happening. So we can see the first bit of output came from where we are debugging. Okay, the debug formatting implemented for integers to print only their value. The dbg call on, okay, outputs the value of ampersand rect1, which is rectangle struct. This output uses a pretty debug formatting of the rectangle type. The debug macro can be really helpful when you're trying to figure out what. Yeah, that is true. In addition to the debug trait, Rust has provided a number of traits for us to use with the derive attribute that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We'll cover how to implement those structs with custom behavior as well as how to create your own traits in chapter 10. There are also many attributes other than derive. For more information, see the attribute section of Rust reference. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work. So you need to do impl area for struct, right? For rectangle. Oh, so. Oh, okay. Impl rectangle function area. See, I could have done. No, right? No, that isn't how it works. That is not how it works, is it? So let me quickly check. And let me make sure that I'm following the chat as well. Alright, so what does it mean? Defining methods. Let's change the area function that has a rectangle instance as a parameter and instead making an area method defining on rectangle struct. Okay, so you do impl rectangle and then you define whatever the functions you need. You take the reference to the self and you don't take the ownership of that, right? You don't want to do that, and that's it. To define the function with the context of rectangle, we start an impl block for rectangle. Everything within this symbol will be associated with the rectangle type. Then we move the area function within the impl and change the first parameter to be self in the signature and everywhere within the body. In main, where we call the area function and pass rect1 as rect1 as an argument, we can instead use method syntax to call the area method on a rectangle syntax. The method syntax goes after, and yeah, that is cool, right? So just a C++ kind of a thing. So in the signature for area, we use ampersand self instead of rectangle ampersand rectangle. The ampersand self is actually short for self, ampersand capital S with self, right? Within an impl block, the type self is an alias for the type that the impl block is for. Methods use must have a parameter named self of type self for the first parameter, so this lets you abbreviate this with only the name self in the first parameter spot. Note that we'll still need to use ampersand in front of the self shorthand to indicate this method borrows a self instance, just as we did in rectangle. Methods can take ownership of self, borrow self immutably as we have done here, or borrow self mutably, just as they can have any other parameter. We have chosen self here for the same reason we used ampersand rectangle in this function version. We don't want to take ownership, and we just want to read the data instruct and then not write to it. If you wanted to change the instance that we have called the method on as part of what the method does, we would use ampersand mute self as the first parameter. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else and want to prevent the caller from using the original instance after transformation. Right, so that is really nice, right? So let's say if I want to do this, suppose I have a struct sample, and if I want to transform, right, and let's say if I want to transform the field 2, okay, right, and what I want to do is I just want to make sure that no one uses field 2 after this. Okay, sorry, sample dot field 2, and it should probably interesting. What will happen after that? Let's see. So let's try this. Okay, impl sample, right, and I'm gonna do function transform. I'm gonna do so let's follow the interesting method here. So what I'll have to do, okay, so of course we are not doing that now, and self dot, let's say we are I don't know. Hey, so what this does, it returns str, right, and let's do, it returns a literal, right? So there you go. And if I do shift k, it is a ampersand string. So this is good. Cargo run. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Okay, for some reason they should fail, right? So why did it not show me the error there, by the way, sir? What happened to you? So something is wrong with doclist. I need to fix it as soon as possible. So it does not expect any argument. Yeah. Dot to string. And here it does not expect any argument. But I want to do it, right? I want to make sure that it gets the ownership. Unused variable, use of moved value sample. Does not implement the copy trait, which is good. Values used here. There you go. That is nice. So that's what happens, right? So if you do sample.field2. Oh, wait. What was the error, sir? Ah, my bad. So I did self. The whole sample has been moved. That means you cannot even use that, right? Okay. But what if I want to use println? Okay, it will work that way, right? Sample.field2. So what will happen then? It will return 3. So we got the field. Okay, because it implements the copy trait. I see, because it's an integer. Hmm, my bad. Interesting stuff. This is nice, yeah. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self in every method signature, is for organization. Right, right, right. We can define a method on rectangle also named width. Yes, you can also have a function, okay, with the name of the variable. That will also work. Here we are choosing to make the width method return true if the value in the instance, okay, if the value is 0, we can use the field within the name, within the method of the same name for any purpose. In main, where we follow rect1.width with any parenthesis, just knows you mean the word, okay. Often, but not always, when we give methods with the same name as a field, we want it to only return the value in the field and do nothing else, right? Methods like this are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, but the method public and thus enable read only. Okay, we'll be discussing what public and private are. Where's the this operator? Okay, array operator in C and C++. Two different operators are used for calling methods. You use dot if you're using calling a method on the object directly, and arrow if you're calling the method on pointer to the object and need to dereference, right? In other words, if object, yeah, right. Rust does not have an equivalent to this operator. Instead, Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. Here's how it works. When you call a method with object dot something, Rust automatically adds in ampersand, ampersand mute or star. So object matches the signature of the method. In other words, the following are the same. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver, the type of self, uh, the type of self. Given the receiver and the name of a method, Rust can figure out definitely whether the method is reading self. The the fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. Yeah. Methods with more parameters, less practice. Okay. This time we want an instance of rectangle to take another instance of rectangle, return true if the second rectangle can fit completely within self, otherwise it should return false. So just calculate the area, right? Yeah, that is true. Mm. Mm. Hmm. The return value can will be a boolean, and the implementation will check whether the width and height. Yeah, that is true. So this is all good. Associated functions. All functions defined within an impl block are called associated functions because they're associated with the type named after the impl, right? We can define associated functions that don't have self as the first parameter and thus are not methods because they don't need an instance of the type to work with. We have already used one of the functions like this, string from function that is defined on the string type. Associated functions that are not methods are often used for constructors that will return a new instance of the struct. For example, we could provide an associated function that would have one dimensional parameter and use that as a both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. So you can have within rectangle you can have a square of just a single parameter and that will return a struct in itself. To call this associated function, we use the scope operator syntax with the struct name, let sq. Yeah. This function is namespaced by the struct, okay, is used for both, okay. Multiple impl blocks, you can have multiple, okay. Mm, yeah. This is valid as well though. Summary, okay. What I want to see is, do I have, okay, first of all, where is it implemented? Function to string. So pubs trait, we have a to-string trait, converts the given value to a string. Example, yeah, string from uh, I.to_string. That will also work. Conversion suggestion, stable, feature equal to rest1 since 1.0.0. Wow. So where is it implemented, my friend? Here it is. There you go. Let mute buff equal to string new. Let mute format equal to core format a new. Bypass format args to avoid write star with zero length strings. Okay. Hmm. This is nice, yeah. String.rs. There's a lot to learn from the source code, right? And these are the good documentation as well that are available. Impl equal and all whatever. And here you have defined impl equal. Enums and pattern matching. In this chapter, we look at enumerations, also referred as enums. If I'm calling it enums, then why do I call it enumerations? It is enumeration. I don't know, enumerations, enums, enums. Enums allow you to define a type by enumerating its possible variants. First, we'll define and use an enum to show how an enum can encode meaning along with data. Next, we'll explore a particularly useful enum called option, which, yeah, that is. Finally, we'll cover how to, if let construct. Okay, that is great. Rust enums are more similar to algebraic data types in functional language such as F sharp, OCaml, and Haskell, which is great. Defining an enum. Enums are a way of defining custom data types in a different way that you do with structs. So let's look at a situation we might want to express in code and see why enums are useful and more appropriate than structs in this case. So we need to work with IP addresses. Currently, two major standards are used. IPv6, IPv4. Because these are the only possibilities for an IP address that our program will come across, we can enumerate all possible variants here. So you can have two variants. So IP address can either be v4 or can either be v6. So okay, we can, there you go. That is good. Okay, that's it. Right, so you can just use, so like sometimes you've seen, right, you have seen people using this thing where they say that focus on the 34th line, which is kind of on the bottom. How can I bring it? Control D, control, nice, god level stuff, man. Sorry guys. So you can do let 4 equal to a sample enum, and you can do 4, right? And you can have a sample enum which says enum sample enum, and you can have 4 comma 5. By the way, this does not mean that it is 4, right? Right, that is totally different. So that is different. Okay, so it's just of a type that, and if I do println, I need to fix it as soon as possible. Sample enum does not implement std form stored format display. So let's do this, and let's derive debug. Where there are errors. It says 5, right? So you see it says 5, right? So it's not like the value is 5 as in the number. It's not 5, right? It's just an enum which says, so there we have. So what you can do later on is you can say, if you can say, actually here you can say number. You can do if number is equal to sample enum 5, then you, hey, we are 5. So you see, you can probably binary operation cannot be applied to type. Okay, so you need to define that. So here you go, right? That does it. Right, so there are just errors which say that. I mean, these are mostly warnings and hints. Consider making the acronym locus except the initial letter 4, right? And that comes from Clippy. But this is intentionally ignored during that code. How do I expand it? Alright, first of all, I need to fix it. Just give me 1 second. GitHub trouble, new vim. So what I mean is there's something that is, wow, look at this. Bismuth. So what is going wrong here? I had, lock list, right? Location list. Okay, sir. I got you. cd config neovim I have used doc list somewhere. I'll go to Lua core mappings.lua and I'll do doc list. So wherever I've used doc list, that will convert to lock list. Wait, what? Why am I using it so many times? Trouble, trouble, Neovim, GitHub. Where is it? Trouble lock list, and this has to be quick fix, right? Trouble quick fix, right? And this has to be LSP references. So it has to be LSP underscore references. Also, that is what I was doing wrong. And if I close this now, if I open it again, and this time if I do, this is GR. Okay, let's do GR. There you go. It gives me the reference. Right, that is good. And if I do XX, so XX is just to toggle that, right? If I need, okay, there you go. You get everything. Let's do XQ. Did it fix anything for me? It did not. That is bad. Trouble quick fix. It did not, because maybe it couldn't. That's okay. Not everyone. Oops. What I want to see is, what is lock list? I don't know. We'll read about it later. Just I'll also make sure that I have said it as config new vim lua core mappings lock list. It is what Excel, right? Like Excel size. All right, so that is something we can look at it later. Enum values, right? You can do this just as I showed you here. It's ideal that you don't keep everything as a caps. Note that the variants of the enum are namespace and is identified, and we use a double colon to separate the two. This is useful. At the same time, we can then, for instance, define a function that takes any IP address kind, and we can call this function with either variant, right? You can do this or this. Using enums has even more advantages. Thinking more about our IP address type, at the moment we don't have a way to store the actual IP address data. We only know what kind it is. Okay, so you can probably store data as well. Struct IP address kind can be there and address can be this. So let home equal to this, and then you can define that. Here we have defined a struct IP address that has two. So you can have a kind field that is of type enum and a address which has a of type of string, right? So that is great. So we have two instances. The first is home. It is a value. Okay. However, representing the same concept using just an enum is more concise. Rather than an enum inside a struct, we can put data directly into each enum variant. This new definition of the IP address enum says that both v4 and v6 variants will have associated string values. Also, you can also have your data inside an enum. Rather than an enum inside a struct, we can put data directly into each enum variant. Okay. So IP address v4, and you can have this v4 storing a string. That is crazy, right? So we attach data to each variant of the enum directly, so there is no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. Right. Very interesting, yeah. There's another advantage to using an enum rather than struct. Each variant can have different types and amount of associated data. Version 4 type IP addresses will always have 4 numeric components that will have values between 0 and 255. If we wanted to store v4 addresses as 4 U8 values but still express v6 address as one string value, we wouldn't be able to do with struct. Enums handle this case here. Crazy, yeah. So because in if you had a struct IP address, right, it will only contain one string data, right? And then you cannot have, data can be either this or that. So data can be only of one single type in a struct, right? But in enum, what you can do is v4 and v6, and both of them can be of different types, right? In a struct, you could have done that as well, but in that case, you'll have to access it by v4 or v5, right? So that is the case. So that is what we don't want to do here. All right. So we have shown several different ways to define data structures to store a version route, right? However, it turns out wanting to store IP addresses and encode which kind They are is so common that standard library has a definition we can use. Also, they have the struct IPv address, IPv4 address, and IPv6 address. You can even include another enum. That is great. Note that even though the standard library contains a definition for IP address, we can still create and use our own definition. We can still create and use our own definition without conflict because we haven't brought the standard library's definition into our scope. Quit, move, write, change color. Quit has no idea data associated with it at all. Move has named fields like struct does. Write includes a single string. Change color includes the I32 value. So that just shows how flexible enums are in Rust, right? Which is to be honest great. So defining an enum with variants such as the ones in listing is similar to defining different kinds of struct definitions, except the enum does not use the struct keyword and all the variants are grouped together under the message type. Right. Okay. So that makes sense. Oh, you can also, there's one more similarity between enums and structs. Just as we are able to define methods on struct using equal, we're also able to define methods on enums. Here's a method named call that we would define on our message enum. Wow, damn, that is great. If you do m.call, it's going to call this. And you can do message write, because here, if you go up, you will see you had write, which takes a string. So you can do that. That's cool, yeah. So the option enum and its advantages were null values, right? So this section explores a case study of option, which is another enum defined by the standard library. The option type encodes the very common scenario in which a value could be something or could be nothing. For example, if you request the first of a list containing items, you would get a value. If you request the first item of an empty list, you would get nothing. Expressing this concept in terms of the type system means the compiler can check whether you have handled the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. Null reference is a $1 billion mistake. Yeah, I've read about it. The problem with null value is that if you try to use a null value as a not null value, you'll get an error of some kind, because this null or not null property is pervasive. It's extremely easy to make this kind of error. A null is a value that is currently invalid or absent for some reason. The problem is not really with the concept but with particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option T and it is defined by the standard library as follows. It can either be none or it can take some of the type T. The option T is so useful that it's even included in the prelude. You don't need to bring it to scope explicitly. Its variants are also included in the prelude. You can use some and none directly without the option in prefix. The option enum is still just a regular enum, and some T are, are still variants of type option T. The T syntax is a feature of Rust. We have not talked about it. Generic type parameter. Yeah, okay, sure. For now, all you need to know is that T means that some variant of the option enum can hold one piece of data of any type, and that each concrete type that gets used in place of T makes the overall option T type a different type. So if you do sum of 5, sum of string, and if you do option I32 equal to none, the type of sum number is option 32. The type of sum string is option m. Okay, because anyways it comes in the option enum, right? And then you're doing some strings, that's gonna, and that's a literal, right? So it's gonna be ampersand star, which is a different type. Rust can infer these types because we have specified a value inside the sum variant for absent number. Rust requires us to annotate the overall option type. The compiler cannot infer the type that the corresponding sum variant will hold by looking at a none value. Yeah, so you needed to annotate it here. Here we'll tell Rust that we mean for absent number to be of option I32. When we have a sum value, we know that a value is present and the value is held within the sum. When we have a none value, in some sense it means the same thing as null. We don't have the valued value. So why is having option T any better than having null? In short, because option T and T, where T can be any type, are different types. The compiler won't let us use an option T value as if it were definitely a valid value. For example, this code will not compile. Yeah, because you cannot add y can be none as well, right? So that's the assumption, because you have not implemented I8 plus option I8, right? In fact, In effect, this error message means that Rust does not understand how to add an I8 and option enum with a type I8, right? Because of different types. Yeah, when we have a value of a type like I8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using that value. Only when we have an option I8 for whatever type of value we are working with, do we have to worry about possibly not having a value, and the compiler will make sure we handle that case before using the value. Yeah. In other words, you have to convert an option T to a T before you perform T. Or you can I add two option T's, sir? Generally, this helps catch one of the most common issues with null. Yeah. Eliminating the risk of incorrectly assuming a not null value helps you to be more confident in your code. In order to have a value that can possibly be null, you must explicitly opt in by making the type of that value option T. Then when you use that case, you are required to explicitly handle the case when the value is null. Everywhere that a value has a type that is not an option T, you can safely assume that the value is not null. So how do you get the T value out of some variant when you have a value of type option T? So you can use that value. The option T enum has a large number of methods that are useful. In general, in order to use option T value, you want to have code that will handle each variant. So you need to use match, right? You want some other code to run? Yeah. I think there's match syntax. Yeah, there you go, the match control. And it's very important. I've seen it being used a lot in the codes. So Rust is an extremely powerful control flow construct called match that allows you to compare a value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things, right? Think of a match expression as being like a coin sorting machine. Coins slide down a track with various, yeah, and then they keep giving that thing, right? So here you go, right? So you're matching coin. If it is of type penny, you return 1. See, there is no semicolon here. That means it's trying to return something, if I'm not wrong. Right? And there you go. It is returning U8. So whatever you return from this thing, from this match syntax, it also returns to this from this function. So let's break down the match. I think I don't need to worry about it. So next are the match arms. An arm has two parts, a pattern and some code. So that is called an arm. So the first arm here is a pattern that is of the value, yeah. And there you go. Okay. That awesome. So when the match expression executes, it compares resulting value against the pattern of each arm in order. If a pattern matches the value, the code executed with that pattern is executed. The code associated with each arm is an expression and the resulting value of that expression. So what is the default? We don't typically use curly brackets if the match arm code is short, as it is okay, but you can also use short. So you can have this curly brace here and you can have multiple functions, and you can see that it returns 1, but it also prints lucky penny. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. This is how we can extract values out of enum variants. Yeah. Let's change one of our enum variants to hold data inside it. From 1999 to 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state value stored inside it. So let's imagine that a friend is trying to collect all 50 state quarters. While we sort our loose change by coin type, we'll also call out the name of the state associated, right? So you can do coin quarter and you can pass the state, right? And you can print the state here. So if you were to call value in cents and you were passing coin quarter, US state is Alaska. The coin here would be coin quarter US state Alaska. That means coin quarter is matched and the state is US state Alaska. When we compare that value with each of the rhymes, yeah, that makes sense. Matching with option T. In the previous section, we wanted to get inner T, yeah. So let's quickly look at this, right? Match X. If it is none, then you return none. If it is sum of I, you return sum of I plus 1. So what this does is it matches, right? And I, let's say it is 5 here. So you'll do 5 plus 1. That means now this will be returned here. So it will, this output is of still option type, right? So it's not like the output type is I32 here. The output type is still option enum. So let's examine the first. So we have done that, right? That is good. Combining matching enums is useful. Yeah, it is useful. It is useful, yes. And we will also look at the result enum, which will have OK and error. ERR. There is one other aspect of match we need to discuss. Consider this version of, okay, let me focus more on the book right now. Consider this version of our plus one function that has a bug and will not compile. You're matching x, sum of I. So what is x? Option I32, it returns I32. You do x. So what if, yeah, we didn't handle the none case, right? So this code will cause a bug. Luckily it's a bug, Rust knows how to handle. So pattern none not covered, okay. So what does it say? It says Rust knows that we did not cover every possible case and even knows which pattern we forgot. Matches in Rust are exhaustive, so we must exhaust every last possibility in order for the code to be valid, right? So especially in this case of option T, where Rust prevents us from forgetting to explicitly handle that the none case has not been handled yet. So catch all patterns and the placeholder. Okay, that is good. So you can do other to catch all the possible matches or patterns. So using enums, we can also take special actions for a few particular values, but for all other values, we can take one default action. So that is what my question was. You have seen it before, right? So how do we do that? So that was what it was suggesting, and that is great. So that's what we can do. So you can match 3 and then you can call this function. You can match 7 and you can call this function. But when, for a default action, you can just do other and you can call move player, right? So that is great. By the way, guys, I know I've just been talking to myself here, but if you guys are here, if anyone is here, please feel free to drop in and say hi. That is the least you can do. Let me know that you guys are here. I'll appreciate that. Okay. So for the first two arms, the patterns are the literal values 3 and 7. For the last arm that covers every other possible value, the pattern is a variable we have chosen to name other. The code that runs for the other arm uses a variable by passing it to move player function. Yeah. So this code compiles even though we have not listed all the possible values U8 can have, because the last pattern will match all the values not especially listed. So this is a catch-all pattern, meets requirement that match must be exhaustive. So right now the match is exhaustive because you have kind of checked 3, 7 and everything else that can be a U8, right? Rust also has a pattern we can use when we don't want to use the value, right? We can just use underscore and that means just, yeah, we really don't care about it, right? So that is good as well. So if you change the rules of the game one more time so that nothing else happens on your turn, if you roll anything other than 3 or 7, we can express that by using the unit value. The empty tuple we mentioned here is a code that goes with, okay. So this is the empty value. This is what we call the unit value, right? So you can just use this and that is it. You're done. So this is great. Here we are telling Rust explicitly that we are not going to use any other value that does not match a pattern in earlier arm, and we don't want to run any code in this case. That is great. So I can just ignore that, right? So here I could have had so instead of saying if number equal to sample number 5, I could have done match number, and I can do probably if it is sample enum 5, I can do println, hey, it's 5, and if it is probably anything else, I can ignore, right? uh, what happened here? Something happened, something broke. I don't see an error, mostly they are warnings, so that is good. And if I try to run this cargo run, there you go. So hey, it says hey, it's 5, right? Because it matched the pattern, right? And if I would have done 4, right, there you go, it will print 3. It will not print anything, right? So basically it did nothing. So the last thing was this. You can say now matching. See, so after now matching, it does not print anything because we have the unit value there. So that is great, right? So we are done here. So there's more about patterns and matching that we'll cover in chapter 18. For now, we're going to move on to if-let syntax. I think that's going to be very interesting. All right. What's the time, by the way? How long we have been streaming? It's 1 hour 9 minutes, which is still not enough. We need to work hard. By the way, guys, today is Sunday. It's a fun day, so we are doing Rust. So chapter 6 should be over very soon, and then we plan to do crates and modules and common collections and error handling and generic types, traits and lifetimes. Wow, that is a lot. I think we'll have to stop somewhere, right? We cannot do everything in a day. By the way, how interesting it is. Writing automated tests is interesting, and IO project building a command line program is interesting. Iterators and all of that is also interesting. Yeah. So concise control flow with if let. So if let syntax lets you combine if and let into a less verbose way to handle values that match one pattern, right? So you can actually do something like um. So we, by the way, like here, what you can do is, wait, let me show you. Right, so you can have if output, let output equal to this. I think this will work. Expected integer found. Oh yeah, right. Now that is great, right? So we can do if let sum of output equal to, is this, can we use this? Yeah, we found I32. That is not allowed. So I can probably use sum 4, sum 5, right? And I can probably just do sum. Oh, I can do none, right? If let, yeah, then I expected a block because it's if. And this will run now. Yeah, there you go. So it prints the output to us, right? That's what we're looking for. So what we do is whatever the output we get from this match, right here, you kind of return it kind of a sum or none type, right? So you remember that we had option enum, right? Something like this. So if I do it properly, this is how it looks like, right? Yeah, I seriously hate this thing. And then we have if let sum of output. So if it matches this pattern, right, then we do this. We can also do this, right? I'll show you. So we can probably do if let none. Then you do nothing. If it's else, yeah, but this is not done, right? I don't know. It has to be option. I can't do this, right? This is not allowed. Where is xt? Yeah, because it's not in the scope. This is interesting. Yeah, I'll have to see, because my question was how do you, I mean, of course, right? You will not. That's the whole point. It's none. You're returning none. You cannot. Right. So that makes sense. So if the value is sum, we print out the values in the sum variant by binding the value to a variable max in the pattern, right? So that's what we are doing here. Uh, Now they say that you want to know this value. So what do you do? Let config max equal to sum. Let's say 3, which is of U8 type, right? And you do if let sum of max equal to whatever the config max. So the syntax if let takes a pattern and an expression. So it takes a pattern sum of max and then it takes an expression separated by an equal sign. It works the same way as a match where the expression is given to the match and the pattern is its first arm. So in this case the pattern is sum of max and the max binds to the value inside the sum. We can then use max in the body of the if let block in the same way as we used max in the corresponding match arm. The code in the if let blocks is not run if the value does not match the pattern. Interesting. So using if let means less typing, less indentation, and less boilerplate. Okay, so we can interesting. So we can do better here. Hmm. So we can include an else with an if let. The block of the code that goes with else is the same as the block of code that go with the default case in the match expression that is equivalent to if let and else, right? So you can do match coin. You remember this was what we were doing, or we could have done if let. So this is the pattern we have coins quarter state, and you can say if it matches, if this pattern is matched for the given coin, then you do this, else you do this. So if you have a situation in which your programming has logic that is too verbose to express using a match, remember that if let is in your Rust toolbox as well. Okay, so what it says is you can do if let sum of number, okay, if this is true for the given number. um mm, if let sample enum 5 for the given number, you can do println and you can do, wait, what is this? Expected. Hmm. Oh, sorry. Yeah, there you go. It works. Hmm. So if for the given number, right, this time it prints 4 to you because it was able to match the number to this pattern and then you have printed it here. So it's kind of an optional another thing that you can do with this. All right. Managing growing projects with packages, crates, and modules. I'm tired for some theory today. I don't want to read theory now. Let's do it tomorrow, guys. So I'm gonna stop here. So remember that tonight I might stream and I want to talk about Bismuth. So I want to continue streaming and I want to do the layout porting. So that is interesting, right? Some point of time I'll have to write. I would love to write it in Rust. So that is good. All right. So today's stream was 1 hour 18 minutes. Is anyone here? Hello. Would anyone mind saying hello in the chat? You might have to log in for that. I'm sorry. But yeah. Huh. Oh, hello. Hi, Tim Axel. Oh, it's such a long time, right? How are you? Thank you so much for joining in. Were you here all this time? I'm sorry, I'm just trying to revise rest. I mean, probably revise and learn again. Sorry. So, what I wanted to do was I wanted to start writing stuff using Rust. So, I wanted to do more, like, for example, writing a code editor, writing something which is useful, writing a language, writing a compiler, writing a linter, So all these things, and I thought it will be good to complete the book before I do anything regarding that. So yeah, long time. I'm fine, thanks. Awesome. That's good to know. What time is it there? Is it early for you as well? Like it's I think 7:40 or 7:50 a.m. Yeah, it is 7:50 a.m. here. What time is it there for you? How do you get people to follow you on Twitch? I don't know. Nobody, nobody even comes to watch the stream, which is fine. I think I'm still learning, so people may not want. Oh, 9:20 p.m. That is great. Are you in the US? What's the time? Oh, it's 10:20 p.m. Oh, you are in Chicago. Oh, right. Interesting. Should be very cold out there. Yeah, so I thought I will stream early in the morning. So I woke up at 5:30, 5:40-ish a.m. And then I got ready by 6:30 a.m. And then I thought that I will stream. So that, something I accomplish in the, like early in the day, that will be good for me. Right? So that's what I was trying to do. Anyways, I think Chrome is really buggy with everything. With almost everything, Chrome feels buggy. And just when I talk about Firefox, it stays. Sorry, we are having trouble getting your pages back. That is weird. Why would you do that to me? I'll clip this thing. So, restore session. No, I don't want to restore session. Please. Don't never restore sessions for me. Anyways, so if I open another window of Firefox. Wait, what is this? Watch. Okay. So this is how beautiful it is, right? You see? This is so cool. Manjaro's website is good. They've even scaled the images. That is nice. And properly, right? See how good it is? Really nice, yeah. I really like how nowadays Linux distributions have started growing things in terms of appearance, display, what people always used to care about rather than performance, which is weird, I know, but still. Anyways, is there any update for Manjaro? Manjaro forum update, latest table updates. Is there any update? Okay. Yeah, KDE 5.25 is not there yet. Activity was recent, 2 days ago, right? So that is okay. So the last was 24th of June. I might expect in the second week of July or third week of July. All right. So that was good. That was a really good stream, guys. Timexur, I hope you enjoyed. I guess only you are here, so that was great having you. Um, it's probably I want to do something. I don't want to leave now. I think I can do better. Um, how can I make my day productive today? I can take some notes, I guess. I don't know. Let's open Chrome. By the way, is Chrome working fine now? It does seem to work. See, it's so cool, right? This is nice. Bismuth is really cool in terms of sometimes it's buggy, only sometimes, and you can just probably fix it, just making the Chrome window floating and then making it tiling again, so it works. So yeah, we just for information. Sorry, I'm so tired today. All right, guys, I think I will leave. Thank you so much for joining in. I really appreciate that. Just for minor information, what I've been working on is Bismuth, and definitely by when I say that, what sorry, when I say that I've been working on it, I mean that I've been trying to contribute to Bismuth. So it's a KDE styling window manager, right? And I'm trying to port everything from TypeScript to C++. Don't It's very important to notice that, to take a note that this is not exactly the port. It is mostly also re-implementing stuff, because that is how it will be done, as mentioned by the maintainer. That's because what the port essentially is the rewrite from ground up. It's not a one-to-one copy because it's just not possible for technical reasons, right? So I've been working on this, and the reason I've been working on this is because I love Bismuth and I use it daily. And if it needs some help, I'm happy to help the maintainer. Um, and that is what I'm trying to do here. Okay. So tonight, if we get enough time and if I have that energy to sit in front of my computer for 2 straight hours after 10 or 12 hours of work, I will do it. So yeah, this is what they have so far. So they have been working on it. It's great. It's great this what this stuff is, but the only sad thing is that of course the maintainer will be busy at times, right? But we want to fix it, right? We want to make sure that we don't um like as a user of a library, you want to make sure that you don't just complain about it. You also make sure that you help improve it, right? That is what you can do as a developer, and that's what I'm trying to do. So yeah, and the direction from the main maintainer was that you can try and port the layouts first because that will be easier to test. And once that is done, then you can try coming back to these shortcuts thing and trying to focus Windows by direction and all of that thing. All right, guys. I have a request. Please, please, please consider following me on Twitch. You know, it will help me in terms of being motivated for the streams. It feels good that people come here and chat with you while you're working, and they look at your work and they suggest something if they have any. Um, I will appreciate if you guys follow me on Twitter, on GitHub, wherever you want, just to stay updated when I'm streaming. Join the Discord channel if you want. And if none of this is possible, that's also okay. At the end of the day, this stream is probably just for good. Okay. Awesome. Thank you so much for joining in. Timexu, thank you so much again. I really appreciate it. Hope you have a good night and hope I have a good day. Alright, guys, that was it from Buffet Codes. This was Kushash Shivishimali here. Uh, and that's it. Take care, everyone. Have a good night, have a good day, have a good afternoon, whenever, wherever, however you're watching this. Alright, thank you, guys. I'm gonna stop streaming now. There's no ending um, song, right? So I can probably sing, but then it will not be a good day anymore. So, yeah, thank you so much, to Max. I'm gonna leave now. Bye bye. Take care, everyone. Have a good night. Do something good night. I mean, do something good today night. Yeah, tonight. Okay. Anyways, I'm gonna leave. Bye. 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 Bye.